hiCams are internet connected cameras between three different locations. When I say they are internet connected, what I mean is they use the internet to communicate, but not in a way that anyone can see, and not in a way that utilizes third-party servers. They are what we call peer-to-peer direct communication. And effectively, the camera on one feeds to the screen in the other location. That's all they do, two-way traffic. But there's three systems. So effectively, there's mine, which you can see both here. Mine are coloured blue, and if you look at the back of these, they're blue. Justin's, which you can see into his studio, his are coloured pink. So I have a pink face here. Jane, and we can see her actually working away there, doing her pottery in her studio, a coloured brown. And this sort of colour coding switches between them. So in Jane's house, the back will be brown and the front will be pink and blue, and so on for Justin. And that's all it is. It's so simple. It's a network. It's a network which has two-way communication between two cameras in each one, and there's two in each location, giving three people connectivity to each other, and they are always on. They boot up, they run, and they do nothing else. They are a very tiny social network between three people and nobody else. So let's have a look at one of these. What I'm going to do is I'm going to unplug one and I'll open the back up for you. So we've lost Justin. Apologies, Justin. I'm just going to take this off here. First of all, I'm going to unplug it. It's a micro USB connection at the back. And I'm just going to lift the back off this for you so you can see what's inside. So it's pretty simple. Let's just get my thumb in there. And there we go. You can see the various constituent parts of a hiCam. If we look inside, we've got the Raspberry Pi computer that I was just showing you, the Raspberry Pi Zero. It connects to a hyperpixel screen. Hyperpixel actually a part of Pi Moroni in Sheffield. It's designed in Sheffield in the UK, not so far from Newcastle. And it has a very small, cheap, I think about £5 Pi Zero camera. The screen costs £40 to £50. It could have been a lot cheaper had we gone rectangle, but there we go. And that's effectively it. There's not anything else to these apart from the physical construction, and I want to talk a little bit to that now. So you might have noticed that I just pulled this off. So all the parts are actually, much to our kind of sometimes gain and sometimes losing, they're actually all push fit. So these all pull apart. I needed to brace the connector so that when you plug this in, it wasn't moving too far. So there's a thing braced across here. The screen, those are the only two screws, apart from the ones mounting the Raspberry Pi. The screen is held in place by a series of pegs. We did that because I didn't want the screen to have anything hard touching it, and the pegs seem to just work nicely. And yeah, so that's it. Screen and camera. One of the motivations for the hiCams was to ensure that they would play nicely with the real world, that the bits that are flowing around the screen and the computer could connect to the atoms of the world around us. So in this case, an IKEA pegboard system, but equally it could be used in a myriad of other ways. There's a practical element to these holes in that computers get hot, they need ventilation, there is no fan in here, there's no moving parts, so it's just prudent to put some holes in, which started me thinking, and I got a bit nerdy here as my training in electronic engineering for many years started to kick in, and a frustration that the standardization of the holes on a circuit board, which has to be kept in a way that you can plug any electronic component, i.e. a chip, into this, is 0.1 separation of the holes, which we see when we're prototyping with the breadboards, that this all lines up, so you can test something here with a chip, and then you can undo it once the circuit's working and hard solder it into your board, cut that off, you've got your electronics. I kind of wanted to do that for the physical world. So actually these holes line up with the holes on here. They're actually every other hole. They're 0.1 inch holes, 0.1 inch apart, so there's probably a case of holding up to the light and you can see that the circuit kind of comes through their lines. So we've made a standard, we've taken a standard that was invented in the 1950s and we've standardized it to allow for holes and affordances of screwing things on. So now anyone that understands this system can say, oh, I'll make for this. I just have to make holes that are 0.1 inch apart or a scalar of that, and I can then start using threaded inserts, the points at which you attach the screws through, and then you've got a system that can go literally anywhere. And just to give you an example of what Justin did with it, was he started to literally go anywhere, and which is why we have pencil sharpener bits you can attach hooks. I call it the parrot hook, I don't know why. The kind of classic phone holder, and so on. All of these are to a standard, and all of them can fit to the back.